Welcome everyone. This presentation introduces Autodesk Revit MEP with the focus of using Revit MEP within sustainable design. During today's presentation, we will review the workflow and design tasks commonly performed using Revit MEP. We'll also review the areas where Revit MEP can be used to drive sustainable design, as well as demonstrate 8 different vignettes covering different portions of the workflow using Revit MEP and related products.
Buildings are the biggest source of emissions and energy consumption. All new and renovated U.S. federal buildings are required to use 55% less fossil fuels by 2010 and be carbon neutral by 2030, according to the 2007 Energy Independence and Security Act. As well, energy retrofit projects nearly always use whole building energy analysis. And studies show that when a design team uses whole building energy analysis during the design, they can save an average of 20% on energy usage. With the help of Autodesk Revit MEP software, MEP engineers can incorporate sustainable design strategies into new building systems design, as well as perform energy retrofits to replace existing MEP systems to help reduce overall energy consumption. And finally, be able to export the design model via GBXML in order to conduct whole building energy analysis.
Revit MEP can be a key tool in creating more sustainable designs. Using powerful information modeling and design visualization techniques, Revit MEP can integrate your BIM model with sustainable design standards and analysis criteria such as LEED. During design, choices are made that significantly impact the sustainability of the building project. Many of these are listed on the left. On the right are examples of goals to achieve sustainability. Designers must understand what factors they can influence and then be able to measure, analyze, and optimize those factors. Of course, Revit MEP can perform a wide variety of work associated with energy use and lighting. Revit supports key aspects of sustainable design by facilitating complex processes and analyses. For example, Revit supports export to GBXML for use in other Autodesk and third-party energy and heat load analysis applications. MEP engineers can use the information created in their computable Revit MEP building information model to test the performance of their design, eliminating the time-consuming task of transferring data manually. And what's more, Revit MEP is now well integrated with other tools to support sustainable design practices. In these vignettes, we will highlight 3 of these products, including Autodesk Green Building Studio, Train Trace, and Autodesk Ecotech. Building information modeling is used for sustainable design because it makes it so much easier to do. Most information required by analysis tools that perform this type of design can be exported from the BIM model, thus saving the architects and engineers from manually inputting this information. This saves time, improves accuracy, and allows the AEs to perform more parametric analysis or what-if scenarios. Some examples of BIM-enabled sustainable design are energy analysis, HVAC load calculation analysis, for properly sizing heating and cooling equipment, or shading and daylighting analysis. We'll be discussing these within the vignettes. There are 8 vignettes within this series, many of which address key sustainability issues. Some of the things we will explore and discuss will include reducing HVAC requirements by improving building insulation, leveraging sustainable design analysis tools, using Ecotech to address LEED requirements, and also exploring alternative solutions that are more sustainable, for example, heat pumps. Also using 3ds Max to perform lighting calculations and improve lighting controllability. And we'll also be leveraging the Revit MEP families from manufacturers for precise energy analysis. And finally, resolving design conflicts to reduce waste. Let's summarize what was shown in this vignette. If you're starting with the Revit architecture model, you can get started immediately because Revit MEP can leverage the same architectural model. By linking to the architectural model, changes made by the architect can be immediately reflected in the MEP environment. Within Revit MEP, spaces are defined to enable the engineer to perform building energy and lighting analysis. Revit MEP has powerful tools to allow you to quickly create and manage spaces and zones. Work sets allow easier management of all the design information, especially when working with a large or extended design team. I knew it. Farts. Let's summarize what's shown in this vignette. If you're starting with the Revit architecture model, you can get started immediately because Revit MEP can leverage the same architectural model. By linking the architectural model, changes made by the architect can be immediately reflected in the MEP environment. Within Revit MEP, spaces are defined to enable the engineer to perform building energy and lighting analysis. Revit MEP has powerful tools to allow you to quickly create and manage spaces and zones. Also, work sets allow easier management of all the design information, especially when working with a large or extended design team. And finally, by using the building information modeling approach, we can ensure that our model is based upon coordinated, reliable, high-quality information, enabling MEP engineers to design innovative projects and to visualize, simulate, and analyze before a project is built. In this vignette, we'll show how to use Revit MEP to perform HVAC requirement analysis. We will then show how we can use Revit MEP's what-if capabilities to reduce the HVAC requirements to improve a building's sustainability. This vignette shows the process of using Autodesk Revit MEP to assign values associated with heating and cooling to spaces and zones within a Revit design model provided by the architect. Once this is done, we'll then perform HVAC requirements analysis using that information to generate a report. This vignette includes the following steps. We start with the version of the model created in Vignette 1 and look at the properties stored with each space. Some of this data will be updated and changed during the review. We then look at the parameters for zone data and again make a couple of changes. It's important that the defined spaces cover the entire volume of the building. So next we'll look to see if that is indeed the case and make any changes required. Finally, before we do the analysis for energy, we need to set some additional factors. We can then perform the energy calculations. Now once this is done, you'll see how we can use Revit MEP's graphic capability to highlight various elements in the model and see them displayed graphically and see the associated energy data. And finally, we'll change some building information such as room occupancy and insulation values and see how it is straightforward to change parameters and rerun the energy analysis. While this vignette shows a very simple example, you can see the power of Revit MEP to quickly compare design scenarios. Revit MEP makes it easy to establish a base scenario for lead analysis and comparison. You also saw how Revit MEP considers building location and weather parameters for that location, and allows you to consider energy use over the course of a day and allows easy evaluation of different building materials.